Hello everyone. In this series of videos, I am going to walk you through the process of creating a RAG application using LangChain.js. So I'm going to be talking about what a RAG application is and a little bit about what LangChain is. In this video, this is going to be a high-level overview of what we're going to be building and what this series of videos is all about. And then in the next video, we're going to go through the 10 steps that through which we will learn about how this application works, and we're going to walk through this application step by step. All this is related to this repository. So all the code that I will be showing is available on this repository. The 10 steps that we will be going through can be found in this step-by-step folder. So we will be going through these 10 steps, and we will also be adding and going through some extra steps. The main file, like the final, let's say, application, basically step 10, can be also found here in the root directory, this rag pdf QA. And so let me start. First of all, I want to tell a little bit more about how I got inspired to create this series of videos and of course this application. This all started while I was watching this video. It's called Beyond the Hype, a realistic look at large language models by Jodie Burchell. I hope I'm pronouncing it right. You will find the YouTube video link in the description below. So basically, I highly recommend that you go through this YouTube video to watch a really nice presentation about the story of large language models and also some key points in the evolution of these technologies. So in this video, you'll find a really nice history of all these technologies that led us to GPT and other large language models. You will also find a part of the video talks about the retrieval-augmented generation. What is this RAG thing? You'll get a high-level overview. And at the end of the video, there is a quick walkthrough of a demo created in Python using LangChain that creates a very simple RAG pipeline that allows you to talk with your documentation. So basically, in this demo, Jodie is loading a PDF from the PyCharm documentation and creates a RAG application connected with an LLM, and then is able to ask questions and find answers related to the documentation. So this application, I decided to transform this, to convert this application into a JavaScript application. So basically it uses the same library, LangChain.js, and it goes through the steps that you will find in the video, in the demo in the video. But I also went one step further, or rather more steps further, and introduced quite a few new things and extras. Let me talk a little bit about what LangChain is. LangChain, you will find the link in the description below. I think this part is what basically a simple explanation. LangChain is basically a framework that is available for both Python and JavaScript, and it's a framework to build LLMs, large language models, by chaining various interoperable components. Let me explain a little bit what this means. Basically, what I like to think about LangChain is that it's sort of like a Swiss Army knife for working with LLMs. Now, usually when you work with LLMs like ChatGPT, you have this simple scenario. So you open up your ChatGPT website, you make a query. In the prompt, you enter your question. Your question reaches the OpenAI server. It goes through the ChatGPT large language model, and then you get a response. So that's pretty much how most of us use these LLMs. And of course, there are other LLMs available like Claude or Gemini. Other companies and services have their own large language models available online. Now, what LangChain does is, on top of this or all the other available LLMs, it adds the ability to connect them with various other tools, so that instead of this simple query response thing, we can load PDF documents, for example. So we have LangChain has this special component that we can connect with any LLM, and then the LLMs can use these PDFs or PDF documents as their knowledge base, so they can retrieve information from our own custom PDF documents. We can also add another component through LangChain to our LLMs, so the LLMs can also browse the web. If an LLM is trained, let's say, in some data that is, let's say, 2 years old or 1 year old, and we really want to find something that's really up to date, we can use a component so that ChatGPT or some other LLM can just go out there, browse the web, find some information, and then give us a response from what it found on the internet. It can also run code, so we can connect an LLM with some LangChain component that allows us to run some code depending on some query or some other action. We can also connect it with an API. So an LLM gives us a response, and based on the response, we can also use another LangChain component that will call an API based on the response, and we will get some kind of other response after that. We can also connect more than one LLM in these chains, as they are called, and we can do some pretty amazing things with LangChain. So this is roughly how I like to think about LangChain, and these are some like basic components, some very basic examples of the components that are available through LangChain. But LangChain has many components and many things that you can connect with your LLMs, and you can do some pretty amazing stuff. So that's what LangChain is all about. Now, what is a RAG application? RAG application, or retrieval-augmented generation. Let me go here to explain a little bit about RAG. So usually, what as we saw in the previous screen, the way that we use an LLM is that as the users are going to be asking, sending some query to an LLM like ChatGPT or Gemini or Claude, or maybe an offline LLM that we downloaded from the Olama website. We just send a query and we get a response back. And the response that we get back, the answers that we get back from these LLMs, are based on what is called parametric knowledge. So basically, you can think of an LLM as a small brain. It has been trained on lots and lots of data, and it has some knowledge that is part of the model. So basically, that's the parametric knowledge is the accumulated knowledge through the training process. Now, all these LLMs have been trained, and they have their own parametric knowledge. So the responses and the answers that we get back are based on this knowledge that they have accumulated through the training process. But there's something missing in this picture. For example, there's something new that just came out. So an LLM that was trained on data from, let's say, 2023 or 2024 or the past year will be missing on things that happened, yesterday or happening today, which means that all these LLMs don't have the ability to learn from information that is coming in like every single day. And this is where RAG applications come into play. So I'm going to go to the next slide. So basically, with a retrieval-augmented generation, you have roughly the same setup. You have a user that is going to be chatting with an LLM, asking questions, sending the queries. But now, instead of just using the parametric knowledge of the LLM to to gather some responses or to get some information back, you are going to be connecting the LLM with some data sources, some PDF documents, some videos, MP3s, text documents, even websites. So basically, this raw data source is any kind of data that you want to provide to your LLM. It can be either static content, like some PDFs that you can upload from time to time, you can update from time to time, or re-upload and upload new documents, or you can also replace this raw data source with the internet. So this can also be the internet. This data source can also be the internet, and the LLM will reach out to the internet to get some information before responding. So on a very, very high level overview, this is what a RAG is. It allows you to add some extra pieces of information to your LLMs so that they gather information from specific documents, specific sources, and so forth. And this also makes it gives you the ability to pass in some private or sensitive data. So you don't want your LLM like to include, let's say, your sensitive information. So you can create like a private application that uses an LLM, and you have this data protected. So these do not have to live on a server. They do not have to be uploaded somewhere. They can live locally on your machine or on a server. So you can keep this raw data private, which is really, really nice. Now let's go one level deeper to kind of like get a more get a little bit more closer to how these RAG applications work. So I broke this down into a few more bits here. So basically, the user queries your data sources. When you want to ask some question, you don't really directly chat with your LLM. Basically, what you do is you use some software like LangChain that redirects your query to these data sources, and there are some smart algorithms that find the relevant data or the relevant documents depending on your question or your query. So if this is a bunch of PDFs that contain information about financial information or medical information or news about the world or whatever, there are some really smart algorithms that will find the most relevant documents from all this bundle, and they will come back with 1, 2, or more documents that contain relevant information. So your query goes through this data source. The smart algorithm picks up the most relevant documents, and then it combines this information, these results, with your user query, and then these things together end up on the LLM as an input, as a question, along with this related relevant data. And then the LLM sends back a response, creates a response, but now the context is derived from these data sources. So it reads the documents that it received, it reads the question, and it gives you a response related with this relevant data. And then I will go one step deeper to explain this into even more details. So what happens is when you create a RAG application, you start with your data sources, which can be any text document or PDF or website or even other formats like video or audio. But instead of just supplying these data sources as raw PDFs or text, they are converted into numbers. They are converted into vectors. So every PDF is converted into a list of numbers. These are called vectors or embeddings, which is the more technical term. It's a special type of a vector. And what you get out of this process is what we call vectorization. So every text document, every PDF, every website is converted into numbers. Now, why do we convert these documents, this text, into numbers, into vectors? Well, because when we convert text into vectors, we can actually use, we can actually place these words or documents or sentences or even paragraphs into what we call the vector space. So this is like a very simple representation of a two-dimensional vector space. So all these, let's say, words end up as vectors in this vector space, and they are not arbitrarily placed here. They're placed on this vector space based on their semantics, based on their meanings. So you will see that we have some words like Paris and France that are close together. We have some other words like Baghdad, Iraq, Al-Khwarizmi, which are closely related in one way or another. So when we want to search something that's, let's say, related with, let's say, these three words, if we want to search about algorithms, our query, so let me just, if we're asking about, like we want to know where the word algorithm came about and get some information about algorithms, we will ask a question. That question will also be converted into a vector. So let's say we're searching for algorithm. And let's say this is kind of like, let's say 4.5. So let me change the color. So our word or our sentence or our query is converted into a vector. And if we place this into this vector space, you will see that algorithm is really close to like Al-Khwarizmi. We got the name algorithm from Al-Khwarizmi. We're close to Iraq and Baghdad because this is where Al-Khwarizmi lived and taught. And the retriever here, the search algorithm, will find the related words and will give us the closest vectors, which correspond to, of course, specific words that are related with algorithms. So Al-Khwarizmi, Iraq, Baghdad are closer to algorithm than Paris or France. So we will get back like all these things. The cool thing is that we can not only vectorize words, but we can also vectorize sentences, paragraphs, and even documents, which means that if we can vectorize a series of PDFs, and then we can search or ask, some question, we can do this vector search on this vector space and find the relevant documents. So not just words, but we will pick up the documents that are closest to, let's say, the word algorithm or to our question. So this is really cool because we are able like to search for semantic similarity using this pretty ingenious mathematics. Once we do this search and our query gets converted into a vector, we then search into this vector space for related words or sentences or documents. We get back some relevant information. So we get, let's say, the most relevant document or documents. And so, for example, a query, we will get like, let's say, this would be the most relevant document. This vector will be compared with this vector. They will be the closest, and then we get back from the vector. Each vector is connected with a document. It's the vector representation of a document. So once we get back a vector that is closer or closest to our question vector, we'll then revert back to the document to get back the text, and then we can pass this information to the LLM. So this PDF will become the relevant data, and along with our question in plain text, the LLM will know how to answer and respond based on this knowledge. So this is kind of like how a RAG application works in a little bit more detail. And I will go, there's one more level here just to get closer to what our application is going to do. Now, in a bit more detail, the data sources like the PDF documents or the web pages or whatever we plan to turn into a vector and store in our database. So every single PDF is converted into a document, and then this document is further split into smaller chunks, as they are called. So if a PDF is, let's say, 10 pages, it will be split into 10 pages, and these 10 pages will be further split into many chunks, maybe based on sentences, on the paragraphs, or on the words or the characters. So a PDF will end up as many chunks, small chunks of text that will further be converted into vectors. So when we want to create this vectorized, let's say, knowledge base, we're not just converting every PDF into a vector, we're splitting the PDF into multiple pages and then into multiple chunks. So small pieces of data, small pieces of text, and these small pieces of text are converted into vectors. These vectors or embeddings end up in what we call the vector store. So basically a database that stores these numbers. And then once again, we can ask the question, our text query will be converted into a vector. A smart algorithm will pick up the most relevant chunks from the vector store. So we will get, for example, document number 2 and document number 6, and these will be passed to the LLM once again, along with our query, along with our question, and we will get a response back. So this is kind of like, in an even more detail, the process of how RAG works. It's still a high-level overview. There are more details. It's a little bit more complicated, but I think it's a nice overview to keep in mind as we walk through the application. So this is all about the RAG application. Now, before moving on to the next step, let me talk a little bit about the paper that RAG is related to this paper. This is a scientific paper that introduced the notion of connecting, the LLMs with some data store. So you'll find a link to this paper if you want to learn more. Two things that you need to have installed in your system if you want to proceed is, first of all, you will need Ollama. Ollama is an application for running large language models locally on your computer, offline. So we will use Ollama to download some large language models and use them so that we don't have to connect to ChatGPT or other remote LLMs. So Ollama it must be installed on your system. It's available for macOS, Linux, and Windows. And you will need Docker. Now, Docker is optional because we will be using it in the extra steps in order to run a vector store called ChromaDB. In the steps from 1 to 10, we won't be using ChromaDB, so if you don't want to install Docker or use ChromaDB, you can proceed without installing Docker. This is the setup. Now I will just start by cloning the application and setting up the code. So what you need to do is first you have to install Ollama. I have already installed Ollama. If you want to check whether you have Ollama installed, you can open up your terminal and type Ollama version, and then you will be ready. So the first thing you need to do is clone the repo. So you will have to go to this repository, grab the code, and go to some folder, and then git clone the repository. Will take just a few seconds, and then once it's ready, you want to change to that directory and start. Okay, it's finished, so I'm going to change to the LangChain rack folder. Let me clear the console. The next thing you want to do is you want to open it up in your VS Code, so you can either go to File and pick open folder or open workspace from File. I will run the command code-a and the current folder, so I will see my LangChain repository code over here. Once you are inside the code, you want to install the dependencies. So there are quite a few dependencies. You will see we have the LangChain and some other npm packages. So you can run npm install to install the dependencies. And you can run the main file if you want to test like this file and see what we're going to get running. This will run like some of the steps that we're going to be going through and ask some questions to a PDF and get back some relevant answers. So it's going to give us 3 responses. We have 3 questions in our code. You have to open the file, and we will get like some responses back from the LLM. We will go through this code and this output in detail, so don't worry. But this is kind of like the final step, number 10. Now, what we're going to be going through is we're going to be, instead of like opening up this file, which is contains quite a lot of information, I have broken this down into 10 easy, simple steps. So we're going to be going through steps 1 to 10 and understanding more how this application is built. So in the next video, we will start with step number 1. Please leave your comments, like and subscribe. Thank you, and see you in the next video.